Hello, welcome to our presentation. Our topic is chi-square distributions. So, before starting with this topic, let me introduce to our group. That is uh, Ajay, Amit, Anshu, and Rahul. So, what we will see in these presentations, let's see the overlook of it. Uh, we will first of all we will see the definitions and the conditions for using the chi-square distributions. Then we will see the properties of chi-square distributions, and next topic will be our the uses of chi-square distributions, and there will be a practical example based on the uses of chi-square distributions, and then we will conclude what we have studied. First of all, the mathematical definition is the chi-square test is useful for the hypothesis testing, and we have to check whether there is an association between the two categorical variables or not. It compares the observed frequency from the data with the frequency which would be expected, and if there is no relationship between, then it will be give our alternative hypothesis. So next to it, it is the PDF of the chi-square distribution. The PDF of chi-square distribution is derived from the PDF of normal distribution. We will not go in depth with that. The second slide was for the conditions which are using for the chi-square distribution. So there are in all four conditions to use the chi-square distribution. The total numbers of frequency in the table should be very large, and the second condition is we will see how to calculate the expected frequency in one of our practical examples, but let's uh, see the conditions before that. The first conditions there is the total numbers of frequencies should be very large, and the second conditions will be the sum of observed frequency and the sum of expected frequencies should be same. Like if we total the observed frequency and the total the expected frequency, they must be same, where the f naught denotes the observed frequency and fe denotes the expected frequency, which we will see in our scenario. Now the third condition is that there should be not at least a single value in the expected frequency should be less than 5. That will be our third condition, and the fourth condition will be like we will do not know any information about the population. So if we don't know about information about the population, so the chi-square distributions comes under the non-parametric test, where in non-parametric test there is no information about the populations, and we have to only check the hypothesis whether there is a significant uh, association or there is no significant association in the non-parametric test. Now, based upon the degree of freedom, now we will see how to calculate the degree of freedom in our practical example. But before that, starting it, we will see based upon the degree of freedom how the shape of the chi-square distribution is changed, and this comes under the property of chi-square distribution. But the first property is the total area under the curve is 1. As you all know, the probability of sum of all probabilities is 1. So this is also applied here. And the second condition is there is an only single parameter, that is the degree of freedom n, in the chi-square distribution. There is no another parameter. Based on the degree of freedom, we have to calculate our mean as well as variance and different uh, central tendencies. And the third point is we can see over here, based upon the degree of freedom, we can check the distributions of chi-square and the shape of the chi-square distribution. Now there is a now we have to start our applications. Okay, the first application, there are in all three applications based upon the conditions. First applications is the chi-square test for independence of attributes. Independence of attributes will only check whether there is an association between the two attributes or not. Like if you want to check the cinema solding tickets and the employed person, like the literate and illiterate, whether there is an association between both the characteristic or not. So the chi-square test for independence of attributes deals with the two attributes, and the second one, in the second case, the chi-square test for goodness of fit check whether the samples which have been collected from the population shows the uh, independently shows about and gives us information about the population. Here in the case we have created a scenario where we have to check whether the demand rate is uniform or not. Like in the population of the demand rate, we have collected some of the demand rates and we have to check whether the demand rate is uniform or not. So our null hypothesis will be the demand rate is uniform, and the alternative hypothesis will be the demand rate is not uniform. These are the two this is the only single attributes. We have to check our hypothesis on the basis of single attributes. Now in the third case, the chi-square test for homogeneity, it depends on the different factor, but it is similar to the chi-square test of independence of attributes, but the calculation for calculating the chi-square calculated and tabulated is different. Let's see how the there is difference between the chi-square test for the independence of attributes and chi-square test for goodness of fit. So in the chi-square test of homogeneity, we will consider the three employment sector, like the people which are belonging to the government employee, the people which are belonging to the corporate, and the people who are self-employed. So we have to check whether they are significantly deposit their monies in the bank or not. Since it is a chi-square distribution, so we have to only check the hypothesis whether they are significantly deposited their money or not, or there is an association between the different employment level and the different employment person which are belonging to a different sector, which are not belonging to the same sector, which are belonging to a different sector, and the deposit of their money to the bank. So here in this case we have to use the chi-square test for homogeneity. Now we will see the practical application in which we have considered a case where we have to check the marital status and the educational qualifications are associated with each other or not. So based upon the applications of chi-square distributions which we have seen here, what do you think, which category will this applications will belong? Like in the first case, like chi-square test for attributes, independence of attributes, or the chi-square test for goodness of fit, or chi-square test for homogeneity. Since we have only two attributes over here, so in which case it will be belonging to? So you are right, it will belong to the chi-square test for independence of attributes. Now we will see how to check whether the two qualifications like marital status and the educational qualifications are associated with each other. So this is our table. The row gives us the information about the marital status, and the column gives us the information about the educational level, and the cell gives us the numbers of people which lies under those condition. Like as we consider the first cell, the never married and the middle school, there are 18 people which are belonging to the never married, and they have studied till the middle school. This is the way the table is created. Our null hypothesis is to check whether there is an association between the marital status and the educational level, or alternative hypothesis is check whether there is no relation between the there is no relation between the marital status and education level in null hypothesis, and the alternative hypothesis there is a relationship between the marital status and education level. And we will 95% confident about our hypothesis. So our level of significance will be 5%. That is 1 minus confidence interval. We will give the 95%. That will give the significance level, that is 0.05. And for calculating the degree of freedom, which we have seen in our previous slide, that the degree of based on the degree of freedom, the patterns of the chi-square distribution is changing. So here in this case, the chi-square test for the independence of attributes, for calculating it, there is a simple formula. The column number, that is marital status, there are 4 column numbers. There are total, in all there are the qualifications, there are total 5 qualifications and the 4 marital status. So this is a simple formula. The column number -1 and the row number -1 that will give us the value of 2L. So our degree of freedom is 2L. Now our major task is to calculate the value of expected frequency. But it is also simple, since we have seen over there some of the frequency I have calculated, but how it has been calculated, it's time to show that. Let's consider the value of the never married and the high school case, that is 36. For that we have to calculate the expected value. So we will go to our row total, and for the particular cell, and the column total for the particular cell, and we will multiply it and divide it by 300. As you all can see, 90 into 90 upon 300, that will give us the value of 27. And this is how we will calculate for the left hand side column, that is 39 into 90 divided by 300, that is row total for the value of 18, row total, and the column total is same as the previous value 90 upon the total, that is 300. This is how all the values has been calculated for calculating the expected values. Now since we have obtained our observed frequency and the expected frequency, we have to calculate the deviations within the observed frequency and the expected frequency, and then squaring it and dividing it by E will, and for calculating the chi-square calculated, we have to sum all of our sum of the columns, like our last column y minus ei upon e. There is no confusion, like the observed frequency which we have calculated and the expected observed frequency which was given and the expected frequency which we have calculated, and there is a simple formula through which we will calculate this sum, and that will be our chi-square calculated. Since we have obtained our chi-square calculated, we have to compare it with the chi-square tabulated. So for calculating the chi-square tabulated, there is a simple process, there is a simple thing, but we have to take the chi-square table, like the chi-square value table. The left hand the row gives us the information about the degree of freedom, and the columns gives us the information about the level of significance. So our degree of freedom which we have calculated was 2L, and the level of significance which was given to us was 5%. So by going to the corresponding values of the 2L degree of freedom and the 5% level of significance, we will obtain the value of chi-square tabulated, that is 21.206. So this is our chi-square tabulated. Now it's time to conclude our hypothesis, like if the conditions for testing the chi-square distribution is, if the chi-square calculated is greater than chi-square tabulated, then we have to reject our null hypothesis. What was our null hypothesis? Our null hypothesis was there is no significance association between the educational level and the marital status. So if the chi-square calculated is greater than chi-square tabulated, then we will reject our null hypothesis. But here in the case, we have obtained with the help of the table, like the chi-square calculated, and with the help of the chi-square tabulated, the two values which we have obtained, we all can see this condition is not satisfied, like the chi-square calculated is greater than the chi-square tabulated. So we have to reject our null hypothesis. There is a significant association between the marital status and the education level. These are some references which we have gone through, and the last slide. Thank you for listening our presentation.